Hello and welcome to this lecture. In this lecture we are going to create our very first model, and we are creating it completely from scratch. So I hope you are excited to build your very first neural network. So I have created here two different files in the folder modeling introduction. One is called end, which is having all the code that we are going to develop, and the other one is called start, because with all the import statements of the packages and some data retrieval and stuff like that, everything that is not related to the actual creating of a network. So you can use this start script, and then we will build the next steps in here. If you're more a different learning type, and if you rather want to follow along on what I'm doing, just watch the video. But I would highly recommend to you that you're actually code with me, because that is a much more productive way to understand actually what is happening here. All right, let's get more space. Now we have everything set up. We have here our start script, and we are going to start by importing the packages. So we are using NumPy, pandas, torch, and then it's a usual practice to load certain submodules of torch under a different alias. So something like torch.nn is usually then imported as nn, just to save some typing. We are also going to use Seaborn for some simple visualization, and that is basically everything that we need for creating the first network. Then we are going to work with some data on cars. Here you can see the head of this data frame. So this is a very classical data frame of which we are going to use two different properties or two different columns, which are the weight and the miles per gallon. And then if we plot this, you can see here the observations. So we have here some decreasing trend. So not surprisingly, if the weight of a car is increasing, then the miles per gallon is decreasing. And then on top, I also put here some regression line, because this is what we are going to replicate with our regression model that we're going to create. So at first, we are going to convert the data to tensors. So we have the data already in cars.weight.values. That would be our first data. And then we can convert that to NumPy. I will show you different ways how to do that actually. So we have the list that we have created before, now converted to some array. Then we also need to specify some data type. So this is some float data. And we need to reshape it. Let's take a look at it. X and P. So now we have here our data with a certain shape, which is basically the way that PyTorch is expecting. So we have 32 observations and one column, one independent feature. And then we are also going to work with the target variable, which is y. This we are going to extract as a list. And now we can convert that directly to some tensors. So I will show you two different ways. One is if the data is already provided in some NumPy format, then you can use the function from NumPy. And then there is another way, if the data is just provided as a list, for example, then you can create a tensor out of it with the known function torch.tensor. Okay, so now we have the data in the proper format. This is the X tensor, and this is our target feature. Okay, we are going to create now our weights. The weights are randomly initialized Basically it's just one value. We have to specify the property requires grad because this is going to be updated. And then we are also going to create that as a float. Similarly, we are going to create our bias. So usually with linear regression, you have a term for the slope and another one for the bias. So here we have the weight and the bias. Then we can specify the number of epochs. Let's say the number of epochs is 1000 and we specify one specific learning rate. The data is fed to the neural network for training, and once all the data is provided to the network, then this is called one epoch. And then the weights are adapted and the next iteration is starting. And then this is the next epoch. So just that you know what the epochs are, because now we are saying we want to iterate 1000 times and provide the data 1000 times to the network, to the training. So we are specifying here that we are iterating over all these epochs with this operation. And then each time we are passing one observation. So this is our inner loop. And now in this inner loop, we are going to calculate our predictions. Let's call them ypred. That is our current observation of the independent feature. So x at the position of I times our weight tensor plus our bias tensor. So this is our forward pass. Then we are going to calculate our loss. So our loss tensor, this is going to be torch.power. So we are creating the square of the difference of ypred, which we just calculated, minus the true value at this current position I. Okay. And now we are having our backward pass in which we are calculating the gradients. So here all we have to do is we have to call the backward function on loss.tensor. Now we are extracting the losses. So this value is basically stored in our losses object .data at the first position. And now we are going to update the weights and biases. And for this, we are going to use the functionality torch.nograd. So in this area, we are now deactivating the autogradient, because now we want to make use of the calculated gradients and assign it to the tensors. And then afterwards we are zeroing out the gradients so that the next iteration can start. Here you can see also one of the functions that is having some underline at the end. This is basically just saying that this is some in-place operation and that the gradients are directly affected with this. So we don't have to assign anything like w.grad equals to something. No, it's directly some in-place operation. Good. Then we are close to the end of this loop. Then we want to see at each end of the epoch the loss value, and we can print it directly. Okay, let's run that and see if it's working. And it's super fast because it's a very small data set. You can see here the losses are decreasing. That is actually what we want to see. And we are done.